Hello everyone! Think about this. Are you comfortable typing your commands in shell? Meh. You can kind of get used to it over time and maybe learn a few tricks here and there, but the truth is, it doesn't have to be that way. By customizing it, you can make it much more comfortable and powerful. I want to show you my setup of the command line. While it's all a combination of bash, fuzzy find, tmax and vim key bindings, today we will focus just on the interactive editing of a command. I'll go beyond the typical well-known party tricks and instead show you the practical settings that let me be effective without too much effort. Here's a couple of useful keys in default bash. When I have a command like echo full bar buzz, I can use Alt-B to go back a word, I can use Ctrl-W to erase a word, and I can finally Ctrl-Y to paste the word back. And of course I messed it up, so it's possible to undo, add the space, and paste it back again. It's not that hard to remember them, but they are just not that natural to me. I prefer to customize it. My preferred shell is bash. If you are not exactly sure about your shell, you can check it in $shell. The default shell on macOS is ZSH, and the version of bash installed is Ancient. You can see it's from 2007. I installed my bash from Mac ports and made sure it took precedence in the path. If you prefer ZSH, I don't judge. You can do the same things with bind key instead of bind. Just check your manual. Bash uses the readline library as its line editor. You can map your keys either in the separate .inputrc file in your home directory, or you can use the bind built-in command in your .bashrc. I was on the edge which option is better to show you. I previously had my mappings in inputrc because in theory other programs also use readline and you can configure them in one place, but this is bullshit. GTB does, but LLDB doesn't. Python sometimes kind of uses it. It's just too much hassle. Instead, I plan to move all my mappings directly to bashrc using the bind command so that I have all my shell customization in one place and to leverage the -x flag for direct bash command execution. As for all built-ins, help is your source of documentation rather than man pages. This is how fuzzy find integrates itself with Ctrl-R. We can see it with bind -x. And this is something you cannot do with inputrc. I'm gonna show you a very simple binding which I find useful. It binds Alt-P to print my working directory. So if I'm editing a longer command, and I'm not sure if I'm in the right place, I can just press the combo and it gets printed without disturbing my line editor. Otherwise, I would have to cancel editing, pwd manually, and then restart editing, which is just too much of a hassle. So how does this bind command actually work? The syntax looks kind of strange at first, but it's actually very simple once you break it down. I can say bind and give it a single string argument with the binding. I use single quotes to avoid having to escape the insides. Inside I have the keystroke which I'm binding to in double quotes, followed by a colon and what it should be mapped to, which could be another key sequence in double quotes. I can also bind a readline command. And finally, with bind -x, I can bind any bash command. So now if I press Alt-1, it's gonna insert my word and go 2 characters back. I can do it again. I can use Alt-2 to go back a word, and I can use Alt-3 to print the channel name without disturbing edit. You can find more examples of keys and commands using bind -p. To understand how to specify the keystrokes, you need to realize that all the input sent from your terminal is just a stream of bytes. All the relevant key presses have to be encoded in some way and then understood by readline. Let's use this short script to see what the terminal is actually sending us. The normal keys are just their ASCII values, so if I type ABC and enter, I can see their codes. You can also see the UTF-8 encoding, like in Czech. You can see here we have the double byte special characters. Control keys have low ASCII values in the same order as the letters. So for example, here is Control E followed by a regular E. This is actually a rabbit hole because Control I has the same encoding as tab. So in order to differentiate between them, you need some tricks. Alt combinations can vary between terminals. In some of them, it will set the high bit. In others, it will prefix them with the escape character, which is hex 1b. In my opinion, the better choice is the escape prefix, which you can see I used in my bindings. What remains is other keys which have much longer encodings. Let's take, for example, the arrows. Here is up arrow, down arrow, alt left arrow, and shift right arrow. As you can see, all of them start from escape and opening square bracket, which is the CSI or control sequence introducer, which is basically a signal that a more complex command like the arrow press is coming. Here the D represents the arrow direction, and the number here is the bit mask of held modifier keys. We can again see Control Alt up, down, left, and right keys. For the ultimate guide about those escape sequences, I recommend the Xterm documentation. I read it all at some point. It's a real good read. Now to actually start customizing my config, I'm gonna remove inputrc and start adding the bindings in bashrc. Let's make sure we only do it in the interactive mode and add the stuff here at the bottom. Now if I create a new window with bash, I have it there. I can also source.bashrc to reload the config. And actually, to make it faster, I'm gonna add a binding for it. Normally with Ctrl X, Ctrl R, you can reload the inputrc config, but since I'm not using it anymore, I will repurpose it for reloading bashrc. Now I just have to reload it manually one final time. Let's think about other mappings I want. Today we're gonna cover just those and leave more ideas for a future video. I want to use Alt arrows to move between words and also use Alt up and down for beginning and end of line, which matches how macOS behaves by default. I also want to delete words forwards and backwards with backspace and delete, use Ctrl Enter to start a new line without executing, and also to move up and down in a longer wrapped command. In addition to moving by words, readline can also navigate by shell words, which respects shell quoting with any white space inside. This is useful for longer text arguments or paths. So let's start hunting for commands and keys. I'll also get the end of line and beginning of line. For literal new line, I need to map it to Ctrl V and then \n. And for up and down, again, we have the commands. With the commands ready, let's go look for the escape codes. Starting with Alt left and Alt right. Left is backward and right is forward. For Control left, we have 7 instead of 3. And here the up arrow is A, down arrow is B. We can already also fill in the screen line movements. Now let's find sequences for deleting words. The forward delete will be Alt delete. And we have a sequence for that. And Control Alt delete is like this. This is Mac. Control Alt delete is okay here. Let's put it here. And we have a 7 instead of 3 for Control Alt delete. Now to delete backwards, I need Alt backspace. And I can see this is escape prefix and the ASCII del car. So it's gonna be escape and then control question mark is the readline syntax for del car. Now for Control Alt backspace, I can see that I get only the escape, which is bad. If I open a new window that is not inside Tmax and run our script here, I can see that there is an actual CSIU sequence for Control Alt backspace, but for some reason Tmax doesn't let it through even though its configuration should allow it. Let's get back to it in a moment and first see how everything works. I can move by single words and I can also move by shell words. I can delete it forward and I can delete single words backwards. The shell words actually respect the boundaries of quoted arguments, including their nesting. Now here is a tough issue and a rabbit hole. What if the terminal doesn't report anything for the key I want, or reports something ambiguous? Like here for Control-Enter or Control-Alt backspace. There are many spots where escape sequences can get lost. Your terminal has some settings and Tmax has related settings as well. Solving an issue might require going deep into manuals, but here is a trick to map anything. In your terminal settings, you should have an option to map any key to an arbitrary sequence of bytes. For backspace, there are two typical encodings. Byte 8, which is ASCII BS, also known as Control H, or byte 127, which is ASCII del. I use del for regular backspace, so I will explicitly map it with the escape prefix for Alt. And for Control Alt backspace, I will use the Alt BS character. But for others, there is sometimes no good logical sequence to map. You could craft something similar to those advanced sequences from Xterm docs, but there is always danger that Tmax will cut it out anyway. So I have another solution. Just like I use Ctrl A as the prefix or the leader key for the Tmax commands, I'm gonna use Ctrl Alt A as the unique prefix for my custom keys. So for Ctrl Enter, I'm gonna do something like 1B 01 0A, which combines this prefix with Enter key. Now in our mappings, del character is Ctrl question mark, and BS character will be Ctrl H. And the custom prefix for Ctrl Enter will be escape Ctrl A \n. And now it should all work. For a final tip, while set -OVI enables VI-like movements and some people like it, its features are limited and I do not recommend it. Instead, look at what Vim offers for editing its command line. You don't get the normal mode motions in command mode. Instead, when you need it, you can press Ctrl F to open history in a full-powered Vim buffer. In Bash, we have a similar thing. Ctrl X, Ctrl E will open your command in your full editor. When you save and quit, the command will be executed. It uses $editor from the environment, so make sure to set it properly. So what are the key takeaways? Your tools should adapt to you and not require that you get used to them. Customize your shell to create your own frictionless workflow. You can map more keys than what's typically available by playing with your terminal settings. And with bind-x there is even more possibilities. I'm preparing another video where we'll explore the bind-x mappings for a heavily customized shell experience. Stay tuned for that. And my challenge for you is this. Find one annoying operation in shell and remap it using the techniques we discussed today. I'm curious what you come up with. Let me know in the comments. Thanks so much for watching and see you in the next one.